Alright, so right now I'm going to do this problem as I did last time. I will copy this over to the journal. Alright, so we're going to have this table A bar, B bar. Alright, probability of A is 0.8, therefore A bar is 0.2. Probability of B is 0.1, therefore B bar is 0.9. And we're given that the probability of A given B is 0.6. So we have probability of something and something is equal to the probability of one event times the probability of A given B. Alright, on this side we'll have those two events, A and B, and the first event on the left hand side must be the probability of B. Alright, since we can't have B first twice. Alright, so the probability of B was given to us as 0.1. Probability of A given B is given to us as 0.6. Alright, so it'll turn out to be 0.06, and that's the probability of A and B, which is top left hand corner. Alright, to make sure all this adds up, that's 0.04. Alright, this must, well, let's do the bottom line. 0.16, and then this must be 0.74. Alright, so that's our table. Okay. Make sure all the numbers add across and down before you move along. Okay. A, probability of A and B bar. A and B bar is equal to, alright, top right hand corner of the table, 0.74. Part B, A or B bar. Alright. Hadn't seen that variety in previous problem. This is from the addition rule. Probability of A or B will be the probability of A plus probability of B, but since we've got probability of A or B bar, there will be plus the probability of B bar minus the joint probability of A and B bar. Okay. If you're uncertain about that, note that the addition rule says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay? Alright, so continuing with this, part B, probability of A is 0.8 plus probability of B bar 0.9. Alright, together those probabilities add up to greater than 1. And so we have to subtract the overlap, A and B bar, subtracted out 0.74, and what if that is? So it's at 0.96, I believe. Alright, let me check my answer. Alright, probability of A or B bar of these parts of the table. Alright, and since the complement of those parts is 0.4, the answer is 0.96, correct. Alright, so that's part B of that problem. C, are A and B mutually exclusive? Well, short answer is no, because probability of A and B is 0.06, and to be mutually exclusive that would have to be 0. Alright, but let's write that out. Alright, if A and B are mutually exclusive, then probability of A and B would be equal to 0, but probability of A and B is equal to 0.06, not 0, so A and B are not mutually exclusive. Okay. D, are A and B independent? If A and B are independent, then the probability of A and B would be equal to the probability of A times the probability of B. Alright, probability of A and B 0.06. Probability of A is 0.8 times probability of B 0.1 is 0.08. Might be close, but it's not the same. It's not equal to. So A and B are dependent. In other words, not independent. Okay. Next, E, probability of B bar given A. Alright, what is that? Well, we make a formula. It's a joint probability across the top, so that'll be, let's not change the order. Right, B bar and A. There's two events with an and in between, divided by whatever is conditioned on the left, so that's divided by the probability of A. Okay, so let's go back to our table and look at that. B bar and A is at 0.74 divided by the probability of A, that's 0.8. Alright, and the answer to that, after I pulled out my calculator, is 0.925. And the next problem, F, probability of A bar given B. Alright, we'll go through the same routine. The two events on the top, A bar and B, divided by the probability of B, since it's conditioned on the left-hand side. Probability of A bar and B, go back to our table, A bar and B, no, that's not it. A bar and B is down here, 0.04. Divided by the probability of B, I believe that's 0.1. Alright. And so the answer to that is equal to 0.4. Okay. And that's that problem. Alright, now let's look at a similar problem, but in this case, instead of formulas, all of the information is given in words. Alright, but still the events A and B are listed as just A and B. Okay, and this will be sort of a step towards a word problem in which you have to decide what A and B are. Again, if you feel good enough about this problem, and you should pause the video here, write down the information that you see on the screen right now, and continue after you've done your best on it.